Hi, this is Lakshmanachari, working as Assistant Professor in Department of Cybersecurity, Institute of Aeronautical Engineering, Hyderabad. Today, we are going to discuss the topic Register Transfer Language and Register Transfer. So, in this topic, we will discuss Introduction to Register Transfer Language, then designation of registers, and basic symbols of register transfer language, and finally we will discuss the register transfer operations. So these are the points we are going to discuss. So let's start with the introduction to the register transfer language. So in general, the digital computer system that exhibits interconnection of digital modules such as registers, decoders, arithmetic elements, and control logic. So these are all the different digital modules, and all these different digital modules are interconnected using some common data, and also using some common control paths to form a complete digital system. Okay, so moreover, the digital modules. So already we have seen the digital modules like registers, decoders, arithmetic elements, control logic. So these are all the different digital modules. So we can define all these different digital modules by defining the registers, and also the operations that are performed on the data stored in the registers. So we can define all these digital modules by using the registers. The number of registers are available, and the operations that we are performing on the data stored in that registers, and the operations performed on the data stored in registers that are called micro operations. So micro operation means the operations that are performed on the data stored in registers. So register is nothing but a group of flip-flops. So whatever the operations we are performing on the data stored in that registers are called micro operation. So these micro operations are the basis for most digital systems. Okay, so these are unlike the operations performed by the assembly language instructions. The micro operations are very simple in action. So that means simple. They are very simple when compared with the assembly language instructions. So the micro operations that include the movement of data from one place to the another place, and modifying the stored values in a register, and performing arithmetic and logic functions. We are performing many arithmetic and logic functions, and finally overwriting a value in register. So these are all the different micro operations. Okay, so first one is the movement of data. So movement, that means movement is nothing but copying of data from one place to the another place. That means we can copy the data from one register to the another register, or we can copy from one memory location to the another register, or we can also copy the data from IO device. IO device means input or output devices to the register. So in this way we can copy from we can copy the data from one place to the another place. So that is a first operation, micro operation. So movement of the data from one place to the another place. Second one is the modifying stored value. So modifying stored value means in general the registers are used to store some data. So that means suppose if you have in a register if you have a register R, so in that some value is there, 53. So we are modifying that value. That means either we are performing some increment operation or decrement operation, or sometimes we will clear the register also. So incrementing means the value, we are incrementing the value which is present in the register. So previously it is 53. By performing increment operation, here the 53 will be replaced with 54. That means increment means the value will be incremented by only 1. That is incrementing. Similarly, decrementing. Okay, so these are all the modifying the stored values. And the third one is performing arithmetic and logic functions. So performing arithmetic and logic function. That means we are performing many arithmetic and logic functions. Arithmetic include addition, subtraction, multiplication, and division. Similarly, we can also perform logic functions. The logic functions include and, or, XOR, not. So these are all the different logic functions. So we can perform all these operations on the registers, on the data which is present in the registers. Okay, so perform arithmetic or logic functions such as adding two values and storing the result in the register. Not only adding, so just before I told different arithmetic and logic operations. So all those operations we can perform on the data stored in registers. So that is the third one. And finally, overwriting the value. So sometimes we will overwriting is in the sense the contents of a register replaced with a new value, with a new another constant value. That is the fourth. So these are all the different simple actions like simple micro operations. And a micro operation. So a micro operation is an elementary operation. It is an elementary operation performed on the information stored in one or more registers. And the result of operation may replace the previous binary information of register, or sometimes we can copy to a new register. Okay, so that means suppose if you have any operation, micro operation, like some add R1 comma R2. So this is one micro operation, add. So that means here the contents of R2 register is added with R1. Suppose if the contents of R1 is 5 and the contents of R2 is 0, 3. So after performing addition operation, the result is 5 plus 3, 8. So that means previously the R1 register, it stores 0, 5. So before performing addition operation, the R1 register, it contains 0, 5 value. But after performing add operation, the R1 register content will be replaced. That means 0, 5 will be replaced with 0, 8. So it will be replaced with 0, 8. That means here we are replacing the previous binary information in a register. Okay, so this is one example. And another one is after performing some micro operation, we can transfer the data to a new another register. That is like move R1 comma R2. Okay, so here the contents of R2 register we are copying to the R1. That means the contents of R2 register copying to the R1 register. So here we are performing copying operation. Okay, so the examples of the micro operations that include shift operation, count, clear, and load, and addition, subtraction. So these are all the different examples of the micro operation. So micro operation means the operations we are performing on the data stored in register. That is nothing but a micro operation. So the internal hardware organization of a digital computer is best defined by specifying the set of registers. Okay. So if you have any hardware organization, that we can define by using a set of registers. The set of registers it contains and their function. So how many registers it contains and how they are functioning. All that registers how we are using. Okay, that is a main one, first one. And second one, the sequence of micro operations performed. So the sequence of micro operations performed on binary information stored in registers. That is the second one. And the third one is the control that initiates the sequence of micro operations. Initiate the sequence of micro operations. So these three parameters will defines the internal hardware organization of a digital computer. And coming to the register transfer language. So register transfer language. Shortly we can call RTL. Register transfer language. So what is RTL? So RTL, register transfer language, it is a symbolic notation. It is a symbolic notation. So it can be used to describe. It can be used to describe the micro operation transfers among register. That is called register transfer language. So it is a symbolic notation that can be used to describe the micro operation transfers. And a register transfer language is a system for expressing in symbolic form. Symbolic form, the micro operation sequence among the register of a digital module. And for any function of the computer, the register transfer language can be used to describe the micro operations. So for any function of the computer, this register transfer language can be used to describe the micro operations. And coming to the designation of registers. So already we know what is register. So register is nothing but a group of flip-flops. A group of flip-flop is nothing but register. So we can define, we can designate the different registers. So we will see how we can designate the different registers. So the registers are designated by capital letters. So first one is the capital letters. So by using capital letters, we can define the, or we can designate the registers, and sometimes followed by numbers. Okay, so the capital letters followed by numbers. So the examples. So here A is a register. A. Next IR. IR means instruction register. Next MAR. Memory address register. PC, program counter. IR, instruction register. So these are all the different registers, and to designate these registers we are using here capital letters. Okay, so that is a one way. One way is the using only the capital letters. The another way is the along with capital letters we are using some numerical values also, that are the capital letters are followed by numbers like R13, or we can also define R1. R1 is a register. R is it is a capital letter and followed by number. So R1, R2, like that. Okay. So using capital letters and the numbers, we can designate the registers. So often the names indicate their function. So these are the some of the registers we are using, frequently using. MAR, memory address register. So this memory address register, it stores the address of the it stores the currently using memory location address, that is a MER. Next, PC. PC means program counter. Program counter. It stores the address of the next instruction is to be executed from the memory. That is the program counter. And instruction register. So instruction register, it holds or it stores the currently executing instruction. That is the IR, instruction register. So in this way, we can designate the registers. And the registers and their content can be viewed and represented in various ways. So that is a register can be viewed as a single entity. It can be considered as a single entity. And the registers may also be represented, showing the bits of data they contain. So the registers, it contains several bits. So all the bits we can show, bits of the data they can contain. So these are all the different ways, several ways to represent the registers. Okay, in general, in 4 ways we can represent the registers. In that, the first way is the representing a register by the name of the register enclosed in a rectangle box. So in general, we are using a rectangle box to represent the register, and also we are specifying the name of that register inside that rectangular box. So here we have specified R1. So the name of the register is the R1. Okay, so this is a first way of specifying the register. And the second method is the individual bits, by showing the individual bits. So the individual bits are from 0 to n minus 1. So can be distinguished as shown in the figure. So suppose if you consider a 8-bit register. So in a 8-bit register, we can store 8 bits of data. So 8 bits means starting with 0 to 7. So 0, 1, 2, 3, 4, 5, 6, 7. So that means here we are specifying individual bits of a register. Okay, so 0 to 7 bits, that means total 8 bits we can store in a 8-bit register. So this is another second way of specifying the register. And the third way is the numbering of bits in a register. Numbering of bits in a register can be marked on top of the box. Top of the box. So this is a register. So here on top of the register you can see 0, 15. So that means from that we can assume that this register is a 16-bit length register. So that means 0 to 15. 0 to 15. So the starting bit is 0 and the ending bit is 15. That means 0 to 15. So that means total it contains 16 bits. So that's why it is a 16-bit register. And the name of the register is a PC, program counter. So that is the third way. And coming to the final last way to represent the register is a 16-bit register PC is divided into 2 parts. So a 16-bit register we can split into 2 parts, like 2 8-bit registers. Okay, so here bits 0 to 7. So this is bit 0 to 7 that can be assigned with the lower byte of 16-bit address. 16-bit address. Okay, so this is the lower byte of the register, and this is a upper byte. So 0 to 7 is the lower byte and 8 to 15 is the higher byte of the register. So in this way, we can the 16-bit register we can split into two 8-bit registers, and we can use this 8-bit registers for two different purposes. So these are the several ways to represent the registers. And coming to the register transfer. So in symbolic notation, it is used to describe the micro operations transfer among registers. So in general, register transfer we can represent in a symbolic form, like arrow mark, this one, like this arrow. So this arrow, it represents the register transfer from one register to the another register. Suppose if you have a register R1, arrow R2, so that means the contents of this R1 register we are copying to the register R2. Okay, so that is a register transfer. So this register transfer in simple we are showing using a symbol, that is a arrow, left arrow. Okay, so it is a kind of intermediate representation that is very close to assembly language, such as that which is used in compiler. So the term register transfer can perform micro operations and transfer the result of the operation into a new register. So it can be the result can be transferred to the same register or to the other register also. And micro operations. So already we know micro operation. So the operations we are performing on the data stored in register, that are called micro operations, and they are detailed low level instructions. So these are the low level instructions used in some designs to implement complex machine instructions. Okay, and coming to the register transfer. So the information transferred from one register to the another register is represented in symbolic form using replacement operator. Okay, so here we are talking about the register transfer. Register transfer is nothing but copying of data from one register to the another register. So that same operation we are representing using a symbol, that is a replacement operator. So replacement operator is nothing but this is a arrow. Okay, so this is called replacement operator. So this replacement operator, it specifies transfer of data from one register to the another register. So in this scenario, transfer of data from R1 register to the R2 register. And coming to the basic symbols of RTL. So in this register transfer language, we are using some symbols. So these are all the different symbols we are using in the register transfer language. So first one is the letters and numbers. Letters and numbers. So already we have seen in designation of registers. So the letters and numbers are using to represent the registers. So like MAR, R1, R2, and so on. Next one, parentheses. So this parentheses can be used to represent as part of register. So like R1 parenthesis 8-bit. So that means the R1 register is it is a 8-bit register. So that means it contains 8-bit information. R1 register, it contains 8-bit information. Similarly, R1 0 to 7. So that means total it contains 8 bits of data. And third one, arrow, left arrow. Okay. So it indicates, it denotes the transfer of information. So here, this R1 arrow R2. So that means the information of R1 register are transferred to the register R2. So this arrow, it denotes the transfer of information from one place to the another place. And next one, comma. So it specifies two micro operations of register transfer. So this it specifies the two micro operations at a time. Like we can suppose if we have two micro operations, so this is one micro operation and this is another micro operation. So these are the two different micro operations. So these two different micro operations we can specify at a time by using this comma. Like so R3 R3 R2 R2 arrow R1. So this is one micro operation and this is another micro operation. So that means here by using comma at a time we can specify these two micro operations. Okay. So for parallel micro operations, to specify the parallel micro operations, we are using this comma. Next, naming operator. So it denotes another name for an already existing register. So here RA is the already existing register. So we are assigning a new name for the RA, that is R1. So that we can achieve with this naming operator, column equal. Okay, so this is called naming operator. So this naming operator, it can be used to specify another name for already existing register. And the last one is the column. So it denotes conditional operations. Conditional. So that means if certain condition is happen, if certain condition is met, then only the transfer of information will takes place. That is a conditional operator. So the conditional operator will be specified by the symbol column. So here you can see. So P column R2 left arrow R1. So that means if P is equal to 1, then only the contents of R1 register will be transferred to the R2 register. Okay. So these are the different basic symbols we are using in register transfer language. Next, hardware implementation. Hardware implementation of controlled transfers. So already we have seen P column R2 left arrow R1. That means this column, it acts as a if statement. It acts as a if statement in the programming language. So if P is equal to 1, then only the contents of R1 register will be transferred to the R2 register. So you can understand this with some hardware block diagram. So this is R1 register, this is R2 register, and this is a control circuit. So this is a control circuit. So this control circuit will generate a signal, that is P. So if P is equal to 1, then only the contents of this R1 register will be transferred to the register R2. So this is a hardware implementation of the controlled transfer. Controlled means here we are specifying some condition. If the condition is met, then only the data transfer will be takes place. Okay. So the same clock controls the circuit that generates the control function and the designation register. And the registers are assumed to use positive edge triggered flip-flops. Okay. And coming to the simultaneous operations. So that means if two or more operations are to occur simultaneously. Okay. So if only a single operation is there, we can directly mention those operations. But sometimes it is required to perform two micro operations simultaneously. So in that case, we can use these simultaneous operations. So that is the simultaneous operations we can specify by using this comma. Okay. So P colon P R5 arrow R3 comma MAR left arrow IR. That means here, so two micro operations will take place simultaneously. That is, transfer the contents of R1 register to the MAR, and similarly the contents of R3 register will be transferred to the R5. So these two micro operations will take place simultaneously if the condition P is equal to 1. So here, if the control function P is equal to 1, load the contents of R3 into R5, and at the same time load the contents of register IR to the register MAR. Okay, so this comma can be used to specify the simultaneous operations, micro operations. And coming to the connecting registers. So how we can connect different registers? So in a digital system with many registers. So in general, if you take any digital system, it contains several registers. Number of registers are there. Okay. So it is impractical to have data and control lines to directly allow each register to be loaded with the contents of every possible other register. So it is impracticable because suppose if you have a 4 registers, if you have a 4 registers, so this is R1, R2, R3, R4. So it is impracticable to connect every register with another register, another possible register. So like this. So this is a way of connecting every register with another register. So what will happen here, as the number of registers increasing, the number of connecting wires required increases. That means complexity will be increases. Okay now. So to completely connect n registers with other registers, we require n into n minus 1 lines. N into n minus 1 connecting lines are required. Okay. So what will happen? Due to that, the cost is high. The cost is high because as the number of registers increases, the number of wires required also increases. As the number of wires increases, the cost also increases because directly proportional. Okay. So registers, as the number of registers increases, the number of connecting wires also increases. As the number of connecting wires increases, then ultimately the cost increases. Okay. So this is not the realistic approach. Okay now. So this is not the realistic approach to use in large digital systems. Like suppose if the digital system contains 20 registers. Okay, so is it possible to connect every register with another register? 20 registers. Suppose if you use 20 registers, 20 into 20 minus 1. Okay, 19 to 380. So 380 380 connecting wires are required. So here n into n minus 1, n where n is the 20. So 20 minus 1, 19. 20 into 19. 19 to the 380. So 380. So 380 connecting wires are required. So this is only for the 20. Suppose if you are having more number than the 20, then it will be the circuit complexity may increases. If the circuit complexity increases, the cost also increases. So that's why this is not the realistic approach. So that's why we have to use a different approach. So that is what is the different approach? That is instead of connecting the registers directly with another register, we are using a centralized set of circuits for data transfer. That is the bus. Bus means a group of wires. A group of wires used to transfer the data. Okay. So that is using these buses we can transfer the data with less cost, and have control circuits to connect which register is a source and which register is a designation. So by using these control circuits, we can specify which register is source and which register is a destination. And coming to the register transfer operations. Okay, so already we know what is micro operation. So the operation performed on the data stored in register are referred as register transfer operations. So basically we have three types of register transfer operations, that are simple transfer, conditional transfer, simultaneous transfer. So these are the three different register transfer operations. First one is a simple transfer. Simple transfer. So R2 arrow R1. So that is a simple transfer. That means in this simple transfer, we are not checking any condition. We are not checking any condition. Whenever we are specifying like this, that indicates the contents of R1 register will be transferred to the register R2. Will be transferred to register R2. So that is a simple transfer. And coming to the second type is a conditional transfer. So conditional transfer. So already we know how we can specify the conditional transfers using P column. So column it can be used to specify the condition. Okay. So P column R2 arrow R1. So this is a way of specifying the conditional transfer. What it indicates? So when the contents of the R1 register will be transferred to the R2 only if P is equal to 1. If P is equal to 1, then only the contents of R1 register will be transferred to the R2 register. So that is a conditional transfer. So here you can see. So the contents of R1 register will be transferred to R2 only if the P is equal to 1. That is a second register transfer operation. And coming to the third register transfer operation, that is nothing but simultaneous operation. So if two or more operations are to occur simultaneously, then we can use this simultaneous operations. So these simultaneous operations we can specify using the comma. Okay. So here you can see P column R1 arrow R2, R2 arrow R1. So that means first so here R2 contents will be transferred to R1. Similarly, R1 content will be transferred to R2. So these two operations will take place simultaneously because both the micro operations we have specified and separated with a comma. Okay. So this is a corresponding hardware implementation. So if these two simultaneous operations will happen only if P is equal to 1. If P is not equal to 1, then that micro operations will not perform. Okay. So this is our simultaneous operations. Okay. So in this video, we have seen the introduction to the register transfer language, and we have seen how to designate the registers, and we have discussed different symbols in symbols used in register transfer language, and finally we have seen register transfer operations. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.